Hello and welcome to this new video. Today we are going to talk about BTRFS. What is it? Benchmarks and more coming up. So yes, today we're talking about BTRFS. So there's actually a lot that we're talking about in this video. We're going to talk about the history, about what is it, how it works, performance, about when you should use BTRFS, how you should configure your system for BTRFS, or if you're not using it, or if you shouldn't use it. So we're going to talk about all of those nice things, but let's start with what is BTRFS. Now, BTRFS, as we know, is a file system, and to be able to understand what this file system is and what it does, we need to understand when it was created. So let's go back a far while, which is 2007. In 2007, the landscape was really different from the landscape that we have today in file system. So when we look at file system today, we have ext4, which is the standard. Back then, we didn't have ext4 as the standard. The standard was its older parent, we could say. It's ext3. So ext3 was the standard and ext4 was just brand new released and not even stable in the kernel. So it was still getting patches to be able to get stable. So we have that brand new ext4 that's coming out. Now ext4 wasn't really fancy in its functionalities, but it was a big leap from ext3 because ext3 had a huge issue, the fact that you needed to declare every block of memory that you wanted to use. Now ext4, the way that they solved it was pretty simple. They created something that's called an extent. Now an extent is a way to declare a group of contiguous memory, so memory that follows each other without any hole in it. So what the extent managed to do in our case is that when you have an ext3 file, let's say that you have a 1 gig file that you want to store, you actually need to store 128 kilobyte of pointers just to be able to store your 1 gigabit file, which is ridiculous. So you would need to read your 128 kilobyte of pointer, you would need to store them in RAM, and then you would need to execute the command to actually read your data, which is slow, which limits the size of your drive, which also limits the size of the file on your drive. That's ridiculous. That's not something that any file system want. ext4 with it extents made it way easier to make bigger file, to have a bigger hard drive, and of course to read that data through the extensive use of extents. That's why ext4 was a little bit revolutionary, so it was a big inspiration for BTRFS, but there's another file system that was a big inspiration for BTRFS, and in that way it would be ZFS. Now, ZFS is an inspiration because it has a lot of functionalities that are in BTRFS today. So when we talk about functionalities, I will just name them. I will explain them later in the video, but there's copy on write, there's snapshots, there's of course a self-healing file system. So there's a lot that we associate today with BTRFS that ZFS already had, and even for a couple of years. So why wasn't ZFS used everywhere in the Linux world when it already had everything that BTRFS has? To start, there's a big problem with the license that makes it incompatible with the Linux kernel. So the Linux kernel, of course, has the GPL. ZFS has a crazy license that was created just for it. Now, those two licenses don't mix together because they're not compatible, making it impossible to integrate it into the kernel. And of course, if we know anything about file system and Linux, if it's not in the kernel, it doesn't exist. So that was pretty much the start of the end for ZFS on Linux, because of course ZFS is extensively used with BSD and Solaris, which was the OS for which it was developed for. But of course, not talking about them, we're talking about Linux here. So the other problem of ZFS is it's a big resource hog. So of course, ZFS didn't manage to have all of those capabilities by magic. No, they did it by just throwing memory at it. So when you actually build a server or a machine with ZFS on it, well, you don't really build it with ZFS, you build it for ZFS, which is a weird thing to think about, because normally when we think, oh, I'm going to use ext4 on my machine, or I'm going to use BTRFS, our mind don't really go to memory requirement. That's not the first thing we think about. We think about, well, actually installing our system. We don't really care about the memory requirement of our file system because it's minimal. Now, that's actually a real thing with ZFS. You need to think about how much memory you have. You need to think about the performance of your system because it's such a big software that you need in the back end to be able to run your file system that's on disk. So they kind of managed to do everything that BTRFS now does by bypassing it, by making it a memory problem more than an actual how to store it on the disk problem. Because of course, if you want to store things on a disk and not use crazy amount of memory to be able to make the magic happen, to make the functionalities happen, well, it will be much more complicated if you don't use that extra memory. If you use extra memory to store a bunch of things, now it becomes way easier to be able to make a system with bigger functionalities. But let's stop talking about ZFS. I was just talking about it, of course, to give you an idea of what existed in 2007. So 2007, BTRFS makes it onto the scene, so people are starting to talk about it, people are starting to do the first code for it, so now BTRFS is starting to exist. So now that we know the landscape of it when it was actually in its infancy, we can a little bit understand its functionality. So let's start by their most important functionality, which isn't B-tree, because yes, even if it's in the name, it's not going to be talked about today because it's not interesting. We're not talking about mathematical things and B3s, and nobody cares about those. We care about things that we can see on a screen, not things that we can contemplate with mathematicians. Nobody cares about this. Well, actually, some people care, but I don't, so deal with it. We're going to talk about copy on write, which is the most famous thing we could say that BTRFS uses. Of course, ZFS uses it also, but copy on write, or also called COW, so COW, is a way to store data on a disk. So normally when you have a file system like ext4 and you want to edit a file, so you just want to change one part of your file, the way that you're going to go about it is to actually rewrite on the disk the actual data. Now, people may be looking at me weird right now thinking, well, how the hell else are we supposed to do it? Well, in a copy on write system, at least the BTRFS way, the way that they're going to do this is, let's say that we only want to edit the last two letters of a file. Well, what we're going to do is we're going to take those last two letters, make a new extent for it, make a pointer towards the first big file, and then note it on the journal. So the journal is the place where we have all the file journalized. So by doing this method, now if we flatten everything, so if we take the new part, the new two letters, and we flatten it with the older full document, we can have the new version of the file. Now you can already kind of see where we're going with this. It gives us a bunch of good things for a file system. Well, let's just go through this. First of all, it gives us self-healing because of course, if it crashes through a write, well, we haven't lost any data, right? Because we can just see the old file and we've lost only the new little part that hasn't been written to the journal yet. So there's no big loss there. But if it were something like ext4 and we were in the middle of a write, well then good luck, because your file is partially written. Now knowing where is the good part from the bad part is impossible, right? You cannot know what character is from the old or the new, and you cannot resume because you don't have a backup of anything. So you're kind of screwed there. But with BTRFS, at most, you're going to lose your new write without affecting your old write, which is really awesome. It gives us self-healing. We can also clone files way easier, because in the file system now is the capability of just having pointers to data and just change those pointers. So we could say, hey, let's have two files on the system that points towards exactly the same file on the hard drive. And when we write on it, we're actually going to have copy number 1 there, and we're going to have copy number 2 that we can write independently. So that's another thing that we can do. And let's go one step further. We can have snapshots. So we can have quick backup, because now what we can say is we can say, okay, all the files that we have there, let's note the journal, let's note how it is right now and copy it somewhere. Not copy the file, just the metadata, just the part where all the files are. Let's note it, let's store it somewhere, and now we have a complete copy of all those files that we can restore, or we can just go in and pick some files out of. So that's actually how the software Snapper works. So Snapper uses those snapshots to be able to, well, give you a backup. So if ever you want to restore an old part of your system, you can, because it can look at versions of your file and be able to say, well, that's the version that it was 1 day ago, so I can restore back to that day. So that's why snapshots exist. So that's the big fun part from BTRFS. It's copy on write. So that's where all the magic happen. But we need to understand that there's a cost to copy on write. And of course it's a bit slower. Let's go even further than that. It's a lot slower in a lot of situations. Now, it's become a little bit more complicated, because back in the day, if we were to talk about this 3 years ago, I would have told you that BTRFS is slower in every scenario and in every circumstance. But that's not the case right now. There's a little bit of a weird scenario where if you have a database that is being harassed by 20 cores at the same time, well, it will actually be a little bit faster on BTRFS than on something like ext4, which is pretty surprising, being that databases are actually supposed to be the big problem with BTRFS and copy on write file system. Because of course, if you have a copy on write file system and you have something that is being written a lot of time often, well, the list of version of that file are going to become more and more and more, and you're going to have a very complicated file. But somehow the BTRFS team managed to find a way to optimize for that a little bit. So when we see, just throw some benchmark on the screen, we can start with 1 core, 4 core, and we can compare all of those. The test that you see on screen right now is a test for inserting, so it's a test for writing data in a database, and the number of thread is the number of insertion that happens at the same time. So as we can see, the more insertion that happens at the same time, the faster it gets. That's probably because BTRFS managed to write multiple extent at the same time, because of course after some time your database is going to get divided so much that you're going to have 1 extent per entry. Anyway, we're not going to stipulate on why it works, but BTRFS normally is slower. So on the aggregate, if we compare, in 99% of cases, it's going to be slower. Now, of course, in that exotic benchmark where your database is getting completely wrecked, it can be faster. So now let's talk a little bit about how we should use BTRFS, because now that we know that it has copy on write capabilities, that we know where it comes from, that we know all of those things, let's use that knowledge to be able to make a perfect system. Now, we're gonna need to do a couple of scenarios here, because of course not everybody uses this machine in the same way, and not every use case will need BTRFS, nor is any use case don't need BTRFS. Some definitely do. So let's start by one really clear one that always needs BTRFS, and that would be the unstable OS, the unstable distro. So by that, now I don't want to offend anybody, but of course, just deal with it. If you use something like Arch, something like Gentoo, you have an unstable distro, meaning that there's heightened chance that your distro will self-destruct just because of an update, because of how bleeding edge your distro is, and because of how much the distro will change in the matters of a few months and years. So when you have something like Ubuntu or even Fedora, all of the updates are vetted to make sure that nothing breaks. In Arch, that's not the case. So when you have something like an Arch, you really want that BTRFS, and you want your whole system to be on BTRFS. Now, if that's your case, it's really important for you to split what part of your disk is your system backup and your data backup. Now, what I'm saying there is that you can actually split in sub-volumes your BTRFS installation, and if ever you need to restore your BTRFS installation, it's way funnier to just restore the part with your system on it if it fails, and not the part with your data on it. But that's something that you can do with sub-volumes. So I'll let you have fun with that with Snapper and sub-volumes. I'm sure you're smart enough to find it. If you use Arch, deal with it. Let's talk about another type of user. And that other type would be the person using something like Ubuntu or something stable like Fedora. There's a bunch more, but something stable that doesn't think his system will break, and also isn't system critical, isn't something that is like a server infrastructure. Because of course, if you have something like a server infrastructure and you can bear the performance hit of BTRFS, you should definitely use BTRFS, because that's just one more tool in your toolbox. Of course, you can restore your server to another date. That's a crazy functionality that every sysadmin want to have. So if you're using something really serious like a server, you should use BTRFS also. But if you use something like Ubuntu, then my rule would change. What I would do is I would do two partitions. So one partition for the system and one partition for OHM. OHM meaning your data. So by splitting those two, what you're actually doing is you can do backups with BTRFS for your data, and your system can be as fast as possible on an ext4 installation. So that actually gives us the best of both worlds, because we have something that is really, really fast for our system, and of course our system is where we need it to be fast, and our data, well, we don't really care as much if our data is fast, because even if it's slower by 1%, who cares? I mean, it's not our system that we will need to reach in all the time. It's our data that we only need to pick in sometime. And having backups of your data is way more useful, at least on an Ubuntu installation, than having backups of your system. When are you using backups of your Ubuntu installation? Well, never, never. Your system is stable. You're just going to update things and it's not going to break. Why would you have a backup of something that won't break? And even if it would break, in the one crazy odd chance where your system would break with Ubuntu, either you really meant it, or second, well, it's time to reinstall. So now there's also the last person that doesn't care at all about its data. Of course, if you don't care about your data, just use ext4 or use something a little bit more fancy like an XFS or a BTRFS, which is brand new, but that's up to you. So now that we know all of those nice things for BTRFS, we can talk a little bit about the future. What's going on with BTRFS? Where are we going with BTRFS? Actually, not that much. The reality is that we're at the end of the line for BTRFS. BTRFS has been in the works for years. It's probably finished when we're talking about its features. And in optimization, there's nothing earth-shattering that we're going to see. We're at the end of the line. We've seen everything. And of course, there's been a lot of problems with BTRFS. If you don't really understand why some people that have been in Linux for a long time don't really like BTRFS, it's because there's been a lot of scandal like the RAID 5 and 6 in 2016, that in 2016 if you use BTRFS for a RAID 5 or 6, well, your data was pretty much gone because, well, it wasn't written right. So there has been some controversy with BTRFS, and of course it's been way slower in the past. It was crazy how bad it could be. And also, I've been personally burned by BTRFS because I've tried their feature where you can migrate from ext4 to BTRFS, and of course it failed in a perfect fashion, let's just say it that way. So yes, even I was burned by the BTRFS functionalities, but hey, that's part of having a file system that is fancy, brand new, and is trying new things. So for BTRFS, we can all agree that it's the end of the line. It's probably going to stay in its current status, and we're going to use it for having more functionality as a file system. So we have the crazy fast ext4 that is as simple as possible, and we have BTRFS, which is a bit slower but gives us way more flexibility on how we can do things. So of course there's a use, and of course I will use it on my installations, and I will recommend that people use it on their installation when they want some snapshot of their data, when they want something that they can roll back their actual computer with. So there's good ways to use BTRFS, of course, but the future is somewhere else. Right now, there's a new file system called BTRFS that, of course, I'm going to make a video talking a lot more about BTRFS, but BTRFS, in a quick couple of words, is BTRFS when made with the hindsight of today. So they try to make it so it's way faster, and we can already see in the benchmark that I've presented before, and I can still show them right now, BTRFS is already faster than BTRFS in some benchmark, and it's not even done, it's not even stable yet. So it's pretty impressive, it's fun to see, and we're all excited to see when BTRFS will go. So if you're hoping for something new to happen with BTRFS, stop hoping right now. Start looking at BTRFS. You're gonna have way more fun. And of course, I'm going to follow all of that in the next Linux kernel and the Linux kernel reviews. So please subscribe. So that's all for this video. I hope you enjoy my ramblings, because of course I like doing them, and if they're useful for you, well, that's good for me. So that's all for this video. I hope you enjoyed, and of course if you did, leave a like, subscribe, do all your good things, and of course, take care.